Okay, hello everyone in a new video in chapter 2, which is the chapter of electric voltage, part 1 for grade 10 students. Then let me start directly with the first section, which is given by electric potential. And electric potential difference. Now, the electric potential difference is known as the voltage difference. So just 1 second, okay. Then for this reason, let's consider a DC voltage source. We know that the symbol of the DC voltage source is given by this. So this is a battery or a DC voltage source that has two terminals. Let's denote the first terminal to be the point P and the second terminal to be the point N. So usually the terminal with the one with the larger length is said to be the positive terminal and the other terminal is the negative terminal. For this reason, we usually denote this terminal by the point P and we denote this terminal by the point N. However, we could have named this terminal to be the point A and this terminal to be the point B, but we always refer to this terminal as the point P because it's positive and this terminal is negative. Why? Because suppose that this battery is of 12 volts. So this is a DC voltage source delivering a 12 volt. So now we know that we can define the voltage of the battery U to be UPN. Now here we must be very careful because we are measuring the voltage from the positive pole to the negative pole, then this voltage is given by 12 volts. Okay, so we are talking about this voltage U. And we know that in this case, if you are measuring the voltage from the negative pole to the positive pole, this will give us minus 12 volts. So in this case, the relation between UPN and UNP is a minus sign, okay? And we all know this from grade 9. Now, in this grade, we will define the potential difference U, so the voltage U, measured from P to N, to be equal to the voltage at the point P minus the voltage at the point N. So let me make it this clear. This is the letter U, this is the letter V, okay? So UPN is equal to VP minus VN, which is equal to 12 volts, okay? So this is said to be the electric potential. At the point P, at P, and Vn is the electric potential at the point N. So recall that in order to define the voltage, we need 2 points, the point B, the point P, and the point N, for example. But in order to define the electric potential, we can define it at any point. So Vp minus Vn is the voltage UPN, okay? And in this case, UNP, so we always start by the first letter, which is N, so it's given by the electric potential at the point N minus the electric potential at the point P, and this is given by minus 12 volts. So why UPN is equal to minus UNP? In this case, UPN is equal to the voltage at the point P minus the voltage at the point N. So now if we reverse the order of Vp and Vn, we have Vn minus Vn plus Vp. So I have just reversed the order of these two. Now taking minus as a common factor, then we will have Vn minus Vp, so it's equal to minus UNP. For this reason, we have UPN is equal to minus UNP, because U represents the voltage or the electric potential difference between 2 points, which is given by VP minus VN. So whenever here we flip these two letters, we gain a minus sign. For example, UAB, independent what the points A and B represent, is equal to minus UBA. Okay, so usually we will refer to the voltage U or the electric potential difference to an electric circuit, but this stands for any 2 points having potentials A and B. Now, for sure, we know that in physics, let me write the following statement. Note, in physics, we cannot add or subtract quantities unless they have the same unit. Okay, so we cannot add or subtract quantities in physics unless they have the same unit. For this reason here we are subtracting VP and VN. So if we take them all on the same side, we have that 0 is equal to minus UPN plus VP minus VN. So in this case, we are subtracting and adding quantities, so they must have the same unit. If the unit of U is volts, then the unit of V and V are volts as well. Okay, so they seem to be complicated, but they are very straightforward. In order to verify, so let's consider the first exercise. So here we have the potential at the point A, electric potential. So usually V, I will refer to it as electric potential, or simply the potential, because here we are talking about electricity, whereas U, I will refer to it as the electric potential difference or the voltage for short. Okay, so let me write this note here, that U, sorry, let me start with V. The V defined at a point, say for example A, is referred to the electric potential at A, or simply potential at A. Okay, so the potential can be defined at one point, whereas for the potential, say for example UMN, this is known as the electric potential difference between M and N. Why the electric potential difference? This is the letter E. Let me make it clear. Why? Because UMN is equal to UM minus UN, sorry, VM minus VN. So it's the difference of electric potentials defined at the point M and N. So it's simply the electric potential difference between M and N, or we will simply refer to it the voltage between M and N. Now let's refer back to this exercise. Given that VA is equal to 100 volts, okay, VB is equal to 98 volts. So here I'm answering the exercise or solving the exercise. Now the electric potential at the point C is given by 150 volts, and the potential at the point D is given by 138 volts. They are telling me to calculate UAB. Notice that here in this exercise we don't have any electric circuit. Previously in grade 9, in order to calculate the potential difference between 2 points or the voltage, we used to have an electric circuit or an instrument that is measuring the voltage. But here the given is that the potential at the point A is 100 volts and the potential at the point B is given by 98 volts. Then UAB can be calculated simply by the formula, which states that the potential difference between the points A and B is given by the potential at the point A minus the potential at the point B, which is equal to 100 minus 98. Plugging this on the calculator, then the value UAB is given by 2. Since 198, both of them are expressed in volts, then the unit of UAB will be volts as well. Then the potential difference or the voltage between the 2 points is given by 2 volts. So notice that here this V is different than this V. So this is a unit and this is a quantity. So sometimes it happens in physics that units and quantities have the same symbol. For example, if you consider G, we can think about it as the gravitational acceleration, which is G is equal to 10 newtons per kilogram, or we can think about it as 8 grams. So whenever G comes after a number, it means it is a unit. Whenever it is preceded before an equal, so it is a quantity. Okay, so this happens in physics. Now, as for the voltage UCD, which is the electric potentials between the points, so we always start by the point C, subtracted. Okay, we subtract the point D, then the value of VC is given by 150. The value of VD is given by 138. Now plugging this on the calculator, then the value of VC minus VD or UCD is given by 12. Since both are expressed in volts, so the value of UCD will be expressed in volts. Then in this case, UCD is equal to 12 volts. Then they are telling me to compare UAB and UCD. Whenever they tell me compare, we need to state that if one is greater, equal, or less than. Knowing that the value of UAB is equal to 2 volts and the value of UCD is equal to 12 volts. Notice that both quantities have the same unit, so we can compare them safely. 12 volts is greater than 2 volts, then we can say that UCD is greater than UAB. Okay? Now in number 2, they are telling me to deduce UBA. Now UBA can be calculated using 2 methods. One of them is to say that UBA is equal to the voltage of B minus the voltage of A. But since they are telling us to deduce, which means that it depends on the previous part. So how come it depends on the previous part? In the previous part we have calculated UAB, which is given by 2. Knowing that the relation between UBA and UAB is a minus sign, so it's minus UAB. Now the value of UAB is given by 2, so the value of UBA is given by minus 2 volts. Now as for UDC, they are telling me to deduce the value of UDC, and by deduce it means that we need to use the previous part. In the previous part we have determined UCD. Knowing that UDC and UCD are related via a minus sign, so minus UCD equal that whenever we flip these two letters, a minus sign is gained. Now the value of UCD is given by 12 volts. Then the value of UDC is equal to minus 12 volts. Now as for exercise number 2, we have that the potential UAB is equal to 10 volts and UAC is equal to 5 volts. They are telling us to calculate UCA. Okay, great. UCA, so we don't have the potentials at the point C and the potential at the point A. However, we have the voltage UAC. We know that UAC and UCA are related via a minus sign. So this is minus UAC. So minus the value of UAC is given by 5 volts. So UCA is equal to minus 5 volts. Now we are asked to determine the voltage UCB. This is a bit tricky, knowing that we don't have the voltage UBC. However, so knowing that UCB is equal to VC minus VB, so solving this type of exercise for the first time, I don't expect to be familiar for the student, but whenever this trick have appeared for the first time, so we must always think about it when encountering this exercise and another problem. Okay, now we don't know the potentials at the point C and the potentials at the point B, but however here what we can do is that we can say VC minus VA, or let me say the following, minus VB plus VA and minus VA. So here what I have done, I have added a 0. So we know that any number, say for example x, we are allowed to add 0 for it because anything plus 0 is equal to itself. Okay, so here I have added this 0. Now I will introduce, okay, I will replace 0 by the following quantity VA minus VA, because this is a 0. So it's VC minus VB plus VA minus VA. Now I will rearrange the following equation and drag this quantity here. So it will be VC minus VA plus, and I will drag minus VB to the right. It will be plus VA minus VB. Now VC minus VA is given by the voltage UCA, and VA minus VB is given by the voltage UAB. Now how come I thought about adding VA and subtracting VA? Because notice that I don't have any relations between the points C and B. So I thought about introducing the point A, because the point A is the link between the points C and B. Okay, so now the voltage UCA is given by minus 5, and the voltage UAB is given by 10. Plugging this on the calculator, then the value of UCB is given by 5. Since this quantity is expressed in volts and this quantity is expressed in volts, so the value of UCB will be expressed in volts. Then in this case, UCB is equal to 5 volts. Now I repeat, when solving such type of exercises, looking at the voltage UCB, we don't know the voltage UCB, so we must think of a point that relates the points C and B, and this is given by A. Going from C to A, then A back to B, so we have the voltage UAC and UAB. So we can think about this in an electric circuit. So suppose that we have an electric component like this. So this is the point C and this is the point B. We are asked to calculate the voltage UCB. So we don't know the voltage UCB. In order to determine the voltage UCB, we can go from C to the point A across another electric component like this, then going from A to another electric component back to B. Okay, so here actually what we have applied, so if you check the relation between this and this, actually what we have done is the law of addition of voltages, okay, as we shall see later. And now let me start with the following section, which is the electric switch. So let me write down section number 2, electric switch. We know that the electric switch operates in two modes, the open switch and the closed switch. So let me say the role of the switch. The role of an electric switch is to open and close, or let me say to switch on and off a given electric circuit. Okay, so let's start with the following mode, which is the open switch. So now, by the way, just a side remark, because we have defined the electric potential difference to be the difference between 2 points, then now we are able to justify a lot of stuff that we used to take it for granted in grade 9, as we shall see. Okay, so let me first start by giving the symbol of the open switch. So the symbol is given by this. Now what are the properties of the open switch? The voltage across an open switch so the voltage across an open switch is equal to the voltage across its terminals. Okay, so another property which is given by the voltage switch, the voltage, let me say an open switch doesn't allow electric current to pass through. Although in this chapter we are not going to discuss electric current, but since we have mentioned the open switch, let me mention the following property. An open switch doesn't allow electric current to pass through. So this is it for the open switch. The important statement is this. We will refer to it back in the exercises. Now as for the closed switch, let me give the symbol of the closed switch. And let me state the first property, which is given by the voltage across a connecting wire is 0. So we know that, suppose that this is the point A and this is the point B, and we are asked that, okay, so forget now about the switch and let's only consider a connecting wire. Now suppose that this is the point A and this is the point B, and we are asked about the voltage UAB. So we directly say that UAB is equal to 0, and the reason is given by connecting wire. But the important thing to notice from here that UAB can be written as VA minus VP. Okay, so comparing these two equations, we can say that VA minus VP is equal to 0. So VA is equal to VP. So whenever we have a wire, let me here recap, do the summary. Whenever we have a wire, so the first thing that we are familiar with, if we have here the points A and B, we can directly say that UAB is equal to 0. But moreover, we can say that the potential at the point A is equal to the potential at the point B. Notice that here, this is the voltage, the electric potential difference. Okay, so why UAB is equal to 0? Because simply the potential at the point A is equal to the potential at the point B. Okay, so number 3, we can say that the voltage across a closed switch is 0, since it acts as a connecting wire. So whenever we are asked about the voltage across a closed switch, say for example AB, then UAB is equal to 0 because it acts as a connecting wire. Moreover, the potential at the point A is equal to the potential at the point B. Okay, so whenever we are considering a point, we are talking about the potential. And here, let me write the following remark. So let's write down the following note. So this is the point A, this is the point B, this is a connecting wire or a closed switch. Then we have that UAB is equal to 0. More importantly, the potential at the point A is equal to the potential at the point B. Okay? And now let's state the laws of additions, the laws of voltages. So now we are in section number 3. Let me write down laws of voltages. So I expect that all of you are familiar with the laws of voltages, and the first one is given by the law of uniqueness of voltages. Then referring to this document, notice that we have a DC voltage source. We have the two electric components D1 and D2. D1 and D2 are connected in parallel. Why? If we name this point to be the point A and we name this point to be the point B, notice that D1 and D2 only have two terminals in common and they are given by the points A and B, so they are said to be in parallel. So we can say that D1 and D2 are in parallel. Then according to law of uniqueness of voltages, they have the same voltage. So in this case we can say that the voltage of the electric component D1 is equal to the voltage across the electric component D2, okay, because they are in parallel. And here let me give the following important remark. We cannot say because U carries one letter, so this is a potential V. This is not a letter, however, this is the name of the electric component. So now we have three notations. Let me do it like this. UD1 and UT2. Now we have three notations and they are given by, say for example, the potential UAB, the voltage UAB, the potential at the point A, and the voltage UD1. Now this U between the points A and B is known as the electric potential difference. Sorry, let me write them again. UAB, VA, say for example, and UD1. So now UAB is the electric potential difference between the points A and B. VA is the electric potential at a given point. We cannot say that UD1 is the electric potential at a given point because these letters A and B, all of them represents points on the electric circuit, whereas D1 represents the name of electric component. It may be a lamp, a resistor, we don't know, okay, a motor. So using these notations, we must be very careful, okay? Now, suppose that in this case, the voltage of the battery is 12 volts. The battery D1 and D2 are in parallel, so all of them have the same voltage, which is given by 12 volts, okay? And now we get to the law of addition of voltages, which is section 3.2, I think. Law of addition of voltages. So usually we use this law in a series connection, but not necessarily in a series connection, in any type of connection, okay? Series, parallel, combination between them. So usually what do we do? And here let me also say the following remark: whenever we are using law in physics, we need to mention the law of the law that we are using. So usually they give half a mark for this statement, okay? So first we need to mention the law that we are using. So let's say apply law of addition of voltages. So how do you apply the law of addition of voltages? Usually we are get used with the fact that on the left we will always write the voltage of the battery, measuring it from the positive to the negative. So let's say in this case that UPN, and on the right hand side of this equation we will move from P to N across different electric components. So we can go from P to the point A like this. We can go from A to the point B like this, then from B to C, then say for example from C to D, from D to E, from E to F, and F back to N. Okay, so this is the law of addition of voltages. What is important in this equation is that notice that on the left hand side of this equality I have started with the letter P. Also on the right hand side of this equation I have started with the letter P. Nevertheless, on the left hand side I have ended with the letter N, as well as the right hand side I have with the letter N. And notice that each letter here I have inserted it twice in order to cancel. So A will cancel up with A, B will cancel up with B, C will cancel up with C, D will cancel up with D, E will cancel up with E, and F with F. Okay, so you can think about it why these letters cancel out and we are left with P and N. Okay, think about defining PA for example as VP minus VA, and defining UAB as VA minus VB. So doing this definition for all of these quantities, you will end up with UPN. Okay, so think about it. Now this one possible equation of the law of addition of voltages, one for example, so this one possible equation. Another possible equation of law of addition of voltages starting with the battery on the left. So let's say also apply law of addition of voltages. Let me start also with the battery on the left, and let's say that UPN is equal to, and let me start with the letter P. So always it's important to start with the same letter. Now, okay, let me go to the point A. But now instead of going to the point B, let me directly go to the point E. So UAE. And now let me go directly to the point F. So E to F. And now F to N. So this is an allowed equation. Why? Here I didn't do anything wrong. I didn't break the rules. Notice that we always have two rules: to start and end with the same letter, and to insert each letter twice. So I have inserted each letter twice, and I have started with P and ended with N. I didn't break the rule. Okay. So let me also give another law of addition of voltages. So let me also write. Okay, it's a good habit to write the law that we are using. So let's also start with UPN. Now instead from going P to A to E, we can directly go from P to E. or let me go from P to A. And now instead from going from A to E, let me go from A to D. Although between the points A and D we don't have any electric component, but this doesn't mean that we cannot define the voltages between the points A and D. Why? Because here we have the potential at the point A and the potential at the point D. So we can write UAD and, for example, UD back to N. So notice that here I didn't break any rule. We have started with P and we have ended with N on both sides, and each letter I have inserted twice, so I didn't break the rules. Now one could ask the following question: which of the following equations or any equation that we must use in solving the exercise? And this depends on the question itself. So let's consider the following example. Let me take this document and move to another slide. Okay, so let's suppose that this is an example, and we have that UPN is equal to 12 volts, and let's say UAB is equal to 3 volts, UBC is equal to 3 volts as well, and UEF is equal to 2 volts, and UFN is equal to 2 volts. We are asked to calculate the voltage UCE. Okay, so UCE can be calculated using law of addition of voltages. So we need to calculate this voltage here. So always whenever solving such type of exercises, so the trick in solving such type of exercises is to write the voltages on the electric diagram itself. So before solving this exercise, let me label the voltages on the diagram. So here it's given by 12 volts. Now UAB 3 volts, UBC is equal to 3 volts, and UEF is equal to 2 volts, and UFN is equal to 2 volts. So usually in grade 9, whenever solving such type of exercises, before we solve the exercise, we label the voltage on the given diagram itself. However, this is what we used to do in grade 9. But now, for example, if we consider the electric component AB, we have 3 volts. So one can ask the following question: am I talking about the voltage UAB or UBA? In order to avoid this confusion, and we will write the voltage itself, which is given by UAB. So here we have that UBC is equal to 3 volts. Now this is given by UEF and not UFE. Notice that here UEF is equal to 2 volts. And here we have that UFN is equal to 2 volts. And UPN is equal to 12 volts. So here what we have done actually, so we have upgraded the method of solving that we have learned in grade 9. And we have modified this method. Instead of writing just the voltages of the electric components, we will write the voltages and including the names or the labels. Okay, now in this case we can apply the law of addition of voltages. So let's say apply law of addition of voltages. So on the left we write the voltage of the battery given by UPN. On the right we write voltages across different electric components starting from P and ending with N, knowing that UCE must appear in the equation. So from P we will go to the point A, from A we will go to the point B, from B we will go to the point C. We are going across this loop simply because we know the voltages across its different electric components. Then from C we will go to the point E, from E we will go to the point F, and F we will go back to N. Knowing that we are interested in determining the value of UCE, now UPN is given by 12 volts. UPA, across P and A we have a connecting wire, so let's say it is 0 and the reason is given by, between brackets, UPA is equal to 0 and the reason is given by connecting wire. Now UAB, the voltage UAB is given by 3 volts. Now UBC is given by 3. Now the value of UCE must be kept as an unknown because we are interested in determining the value of UCE. UEF is given by 2 and UFN is given by 2. So here we have that 12 is equal to 6 plus 2, which is 10, plus UCE. So what's the type of this equation? This is a linear equation and one unknown. The unknown is given by UCE. How do you solve this equation? We put UCE on one side and all the other numbers on the other side. So UCE in this case is given by 12 minus 10, which is equal to 2. Since both 12 and 10 are expressed in the SI, which is volts, so UCE will be in volts. So UCE is equal to 2 volts. So since we have calculated the value of UCE, let me label it here that UCE is equal to 2 volts. So this is what we have done in grade 9 with a bit of modification. When labeling on the diagram, we need to label the voltages in addition to their labels. But now let me introduce a more efficient way in order to calculate the voltage UCE as follows. Okay. So let me do a small recap. We have calculated the voltage UCE based on the fact that on the left we wrote the voltage of the battery, which is given by UPN. A more efficient way to solve this problem, knowing that we are interested in determining the value of UCE, so let's directly on the left write the voltage that we are interested in calculating. Now in this case we will go from the point C to E across different electric components such that we know their potential difference. So in this case we need to go from C to E. So in this case we'll go from C to B because we know this voltage. We'll go from B to A to P, P to N to F, F to E. Okay? So from C to B plus B to A to P plus P to N plus N to F plus F to E. Notice that this is an allowed law of addition of voltage equality because we have started with C and started with C, ended with E, ended with E, and each letter we have inserted twice. So we are allowed to use this equation. And as a verification, we know that the value UCE must be 2 volts. So we expect that the value of UCE must be 2 volts, which is a check that our equality is correct. Now UCE is equal. What's the value of UCB? Here we have that UBC is equal to 3 volts. UBC is equal to 3 volts, which means that UCB is equal to minus 3 volts because whenever we flip these two letters, we gain a minus sign, so it's given by minus 3 plus UBA, we know that UAB is equal to 3 volts, so UBA is equal to minus 3 plus UAP, independent whether we are measuring from P to A to B, the voltage UPA is 0 because if UPA is equal to 0, then UAP is equal to minus 0, which is 0. So this is also minus, 0 plus UPN, great, UPN is a 12 plus UNF. Notice that here we have that UFN is equal to 2 volts, then UNF we have a minus sign because we flipped the letters, plus UFE. Notice that UEF is equal to 2 volts, so simply UFE is equal to minus 2 volts. Now this is given by minus 3 with minus 3 is given by minus 6, with minus 4 is given by minus 10, plus 12. So minus 10 and plus 12 it's given by 2. Since both these quantities are expressed in volts, so the voltage UCE will be in volts. So UCE is equal to 2 volts. So as a general rule when solving such type of exercises is that In addition to writing the voltages of the electric components on the given diagram, we need to write the correct label for each. And when applying the law of addition of voltages, we will write on the left the voltage that we are interested in calculating instead of writing the voltage of the battery. Okay? So that's it for me in this video, guys. In the next part, we'll complete the explanation of this chapter and solve some extra exercises.